Hello, welcome back to Cracking the Cryptic, and today we're looking at a puzzle called Pi V Squared Snake by Tulrak. It's pretty much exactly half a year since Pi Day 314. We're in September now, so we're getting close to 914, and I think this is worth doing anyway. It's fascinating, and we get to learn or remember, for some of us, not me, the first 25 digits of pi, which is fascinating. So I'll have a look at the rules in a moment. Don't forget that still time to enter the Patreon competition. The 20th is the deadline to enter lines and shapes. Do join us on Patreon. Have a go at that hunt. It's very popular. As are our apps, which are all available again in the links under the video. Follow your way to the apps and get one or two of them because they are great fun. We're still working hard on more. And we've got, what else have we got going on? You can also check the links in the Discord server to our merchandise, Sven SUDOKU PAD, the Discord server, the catalogue of all our videos. And the first link is to this puzzle, Pi V Squared Snake by Tulrak. And the rules are relatively straightforward, actually. Normal Sudoku, I'll get back to pi in a moment. Normal Sudoku rules apply, so we're going to put 1 to 9 in every row, column, and 3 by 3 box. Hurrah. The cage shows its sum, which is 23 for those 3 digits. A clue outside the grid, so this 15 and this 6, show the sum of the indicated diagonals. So those 3 will add up to 15. Digits joined by a V must sum to 5. All possible V clues are given, so that's a little negative constraint for me to forget later. And now here it comes. We draw a 25 cell long, 1 cell wide snake made of orthogonally connected cells that doesn't touch itself, not even diagonally. So that snake could look something like this. Mustn't touch itself, remember. So I don't know when I've got to 25 cells. Might be something like that. The snake contains the first 25 digits of pi in the correct order, going from the snake's head to its tail, ignoring the decimal point. So we will start with a 3. I will presume that in the rules of the puzzle as printed, these are the 25 digits. It would be very cruel if Tulrak has only given us the first 24 there, wouldn't it? I'm sure that's not the case. Right, do give it a try. I'm going to have a go. And I'm going to restart my clock and say, let's get cracking. Well, I'll be doing colouring in a moment, I think. This is 1, 2, 3 because of that 6 clue. That's all it can be. Yeah, I'm going to just launch in and colour blue. Blue for digits from 1 to 4 because all of these V things must contain digits from 1 to 4. To add up to 5, they have to be smaller than that. And maybe we can get something done about the flavours. Those two add up to somewhere between 11 and 14, and they only use the higher digits. Okay, I'm also going to now colour orange cells between 5 and 9. So sometimes in puzzles I will use orange to mean 6 to 9, but this time I think it may be more useful to do 5 to 9 because we've got some rows and columns where there are already 4 blues and boxes. I might have missed, yeah, there's another row. So these are definitely 5 to 9 in the orange. Okay, I don't know quite what that's told us yet. Maybe we need to start with the snake. That would be astonishing. No, I'll tell you what I'll do. I'll start with the negative constraint. These two are going to be orange because that is one of the pairs of digits that make up a V. Say it's 1 and 4. Then this is 2 or 3, and it mustn't be next to another 2 or 3, or else there would be a V. So those are orange. Now I've got... Oh, I already had 4 blues in this column. But anyway, I found that was orange this way. Similarly, we've got an outlying cell there. The one next to that is not orange, is not blue, is not the other 1, 2, 3, 4. The one next to this one in column 4, I can colour. It doesn't apply up here though, because that would match with that digit. So there's lots of places where I can't do this. I can in this row. The cells next to this one mustn't be the remaining digit from 1, 2, 3, 4, or it would kind of join on to this one. So I don't know how much that has advanced me. What I would like to do, to get quite scientific about this, is get all the orange cells, all the blue cells specifically, filled in the grid. Then we'd find out where 3.141 was, I think. I don't know. I can't work out if we're going to determine the digits, some digits in the puzzle first, or have to use the snake to do that. That's quite hard to figure out. Okay, what I'm going to do is colour the V's. Any two V's connected together, let's call these green. And they might be 2, 3, or they might be 1, 4, but they must always cleave together, as it were. So the other colour is purple. Now these can't be the same because there's two greens looking at that cell, so that's a purple. So there's going to be two greens and two purples in each row and column, and greens always stick together and purples always stick together. Those are quite unamicable colours. So those are purple, and that's purple because it sticks to the other purple. Those are green. Yeah, this is useful. Those are green. Those are purple. Those are green. So I get to colour all these flavours of 1, 2, 3, 4. Now I can see that these two can't be green or purple because they see all of those. This can't be purple because it sees... No. Yeah, that's right. This can't be purple, so it's orange. This is a purple digit. This one is the last one in its row. It must be a blue. Where else are we seeing two? This one sees two purples and two greens, so that's orange, and therefore this one is blue. I've just coloured that the wrong colour by mistake. Yeah, I mean, this is interesting. One of these is the rogue purple digit in that row. Oh, this is so straightforward. These two are selected from 1, 2, 3, and now I know that they make up a V. Oh, so obvious. So that's the 2, 3 pair. So purple is the 2, 3 pair. Let's just colour that cell purple, highlight all the purple, and then make them the 2, 3 pair, sorry. And we'll then make all the green, highlight one green, there we go. We'll make all of them the 1, 4 pair. There we go. Okay, so that wasn't green, in fact. One of these is green, and I don't know which one. Yes, I do. It's not here because that sees both green. Oh, I'm so bad at doing, I mean, it's the right strategy. I'm just not very good at executing it. Right, that sees 2 green and 2 purple. This can't be purple or it would get a V with that. Yes, that's definitely a solid deduction. There we go. Okay, we've got a lot done now. That is exactly the same digit as that, so they don't rule about this one. I'd still like to do more. I'm very greedy, I know. But anyway, we know now that we now know the flavours. Now maybe we can think about, okay, because pi begins 3.141. And that 141 is like green, 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 which looks like it could well be there. Oh no, it could be, well, it can't be here because you can't start with a 3 connected to one of those two, which is quite interesting. Now, is there anywhere else we could get 1, 4, 1? There is. It could be here. So just need to be careful. Yeah, that could go 3, 1, 4, 1 there, or this could go 3, 1, 4, 1 here. So I might need to do more colouring, and I'm not sure if I can. Can that be a 1? Yes, easily. Can it be a 4? That's a bit harder, but this could be a 5, 6 pair. Actually, maybe we need to think about what the continuation would be after the 1, 4, 1. If this went 3, 1, 4, 1, we're then going to need to find 5, 9, 2, and then 6, 5, 3. I don't know. It's interesting. It's like, I think we're going to have to identify a maze, which is a weird way of going about the puzzle. So there's one purple here. There's one purple here. This can't be green, actually, because it can't be the same digit as that, and it can't be that digit because there would be a V. So that is orange. Oh, maybe I've just missed some. So these are both blue. I don't know which way round they go yet. Yeah, that's interesting. That's a way of looking at it that I hadn't thought about. But I don't see why this couldn't be purple. I'm really not sure I can do these remaining colours at the moment. I think I'm going to have to look for pi, which is annoying. But, okay, where can that 1, 4, 1 thing happen? Because it has to be a pair in one box and then another box. I suppose it could, in theory, go round one of these corners, but there are actually none of these corners that will allow a 1, 4, 1. So it is 2 digits in one box that are next to each other, and then 1 digit in an adjoining box. And that's interesting, because the 1 digit where we don't know where 1 and the 1 box where we don't know where 1 and 4 are is here, but it can't connect to a green in an adjoining box. So we don't have to worry about that. This doesn't, and this doesn't. So this we've ruled out because the 3 can't start off the string. So the 1, 4, 1, oh, it can't be here anymore because we worked out that's not green. It is up here. We've done it. Here is the head of the snake. 3 there. Yeah, this must be right. 1, 4, 1. Yes, I used to think the snake could start here, but now that that can't be a 1, that's wrong. So this is the snake's start. Okay. I'm finally away now. There are Sudoku that I can do as a result of getting that start. Now, that's a 2, 4 pair. I really don't know how they operate. And I don't think I can follow these digits down the grid until I continue the snake. Now, we're going to go 5, 9, 2, and then a 6. So forget that 2. 5, 9, 2, 6. 5, 3. Well, we could. Oh no, the snake doesn't touch itself. Oh, that's vital. Okay, I need to be drawing a snake line. So the snake is a black snake. There we go. So where is that going to go? It mustn't touch itself, so it doesn't go here. It goes either here or here for the 5. And then the 9 is going to have to be here. It can't be here because the snake will die in the corner with the 2. So that's a 9. And then it's got to hit 2 here. That's got to be right. And then it's got to hit a 6, and that must be here. Then it's going to go 5, 3, 5. Well, the snake doesn't touch itself, so it's got to go here for the 5, here for the 3. Okay, let's draw some of these snake lines in. Oh, let's do some Sudoku now. Got a bit more we can do. 2 and 3. That's probably about all for now. Oh no, that's a 2. Actually, that's more. 3, 2, 3 there. I can put in a 3 here. Now I see the digits. Maybe I could... Oh, 3 in the corner. That's 3 in the corner. That's 3 in the spot. Light losing its religion. Okay, so now that's got to be a 2, I think. And that's going to resolve my 4-2 pair up there, which is reasonably useful, possibly very useful. Might as well keep colouring them because we began, we might as well finish. I don't know what to... Oh, these are both orange, I can do that. Then I've got a 2x2 I can't colour. Sorry, I've got an itchy eye now, I don't know what I did to that. Right, so 3.141.5 by Sudoku now can't be there, so it's here. And that keeps the snake, keeps the snake going at the top. There we go. So we've got the snakes beginning. 3.141, 592, 653. Then we're going to get 58979. That's a lot of orange digits, isn't it? Could come this way. But then it would go 589. And then it couldn't get to another 9 because it would be in the same box. Wow, so it's going to have to go up here. That's right. It mustn't touch itself, the snake. 5, 8, 9. Now, we can't go up there because 9 would clash again. So we've got to go here. 5, 8, 9, 7, 9. I think that's got to be right. I wonder if I'm going to end up having learnt 25 digits of pi. I really don't think so. So 5, 8, 9, 7, 9. We've got about 10 digits to go. 3, 2, 3. Ah, well, that makes sense. We know how to do that. Then 8, 4, 6. 2, 6, 4, 3. How are we going to reach a 4? In 2 digits from here, the 4 is going to have to be here. Yeah, and that's going to sort out quite a lot of 1s and 4s. 4, so it's 3, 8, 4, 6, 2, 6. Well, we've got to go through this 2 to get out of the box. And in fact, to go through that 2, without touching ourselves, the snake's going to have to come down here. 3, 8, 4, 6, 2, 6. And then 4, 3, yes. We can see how to do that now. There we go. And I think the rest is just finishing off, which hopefully I can do before my... If I got caught in my eye... goes too badly wrong. So 4, 1, 1, 4. Now let's just do the last bit of colouring. We're going to get those as blue green. I tried to do the green there, and these as orange. Right, and let's just finish off 4s first of all. What 4s have we got? We've got 1 to do, and it's there. We can do the 5 and the 7 in box 1, 5 there, 8. I mean, this is just relatively trivial Sudoku now, which is great. That's where I like puzzles to get to, because I am not Simon Anthony. 6 and 8 here, 8 and 6. I can do 7 there. A 5, 9 pair puts the 9 in the cage. 93. This is 8, 5, 6 in that order. Now 8 and 9 over this side. That's a 7. I've got 7 and 6 to put in row 6. 9, 8 at the top. That's a 9. 6, 4, and 3, 2. So 9 and 5. 8 and 7. I think this is right. 5 and 7, 2 digits to unwind. 5 and 9, and there we go. That's it. That is the pi snake. That is a lovely idea. Pi v squared snake. Not too difficult a puzzle, as long as you kind of have the right approach. I should have been a little quicker with the 1, 2, 3 pair down here. I should have, yes, the obvious thing to do is go, that's a 1, 2, 3, that's clearly a 4. Didn't do that for ages, but it didn't really matter. Lovely puzzle. Thank you, Tulrak. Hope to see you guys again soon on the channel. Bye for now.